All right, viewers, welcome to Solid Electrical page. This is Solid Tech, and I'm here to introduce to you this Schneider relay. As you can see, this relay is called a 12-way relay. It's normally called 12 pin. It's normally called 12 pin. So you know that relay works like contactor, but this one is a different ball game. Now this is how it works. This relay can be energized. If you energize this relay, it is going to help you to perform different functions. Now when you energize this relay will open and close. It will open and close about 4 places. It will open and close in 4 places. Now this is what it does. There's a particular number where you are going to energize it. Now usually relays you can energize from 13 and 14, and because of the camera quality you may not be able to see what I am doing very well, but if you can lay your hands on this kind of relay, you will see that the relay has number 14 and 13. Usually 14 is positive, 13 is negative. But if you want to learn how to do it, if you look at the relay itself, the body, they usually indicate where you will power it from. You will see 13 is A1, while 14 is A2. You will see it on the relay, and it is also indicated there. The electrical diagram is there. You will see that number 12 is common, and number 4 is normally closed. So meaning that number 12 and number 4, they are normally closed. When the relay is not powered, it's closed, like it's switched on, it's connected. Why number 12 and number 6, number 8, they are normally open when the relay is not energized. So when the relay is not energized, when you power the relay, then it will now turn the other way around. It will be upside down. So meaning that if you energize this relay from A1, A2, which is 13 and 14, the number 12 and number 4 that was normally closed before will now be normally open. They will now open. So then number 12 and number 8 that is normally open before will now be normally closed. I hope you understand this. So that is how relay works. And this is it. So it is not only number 12 and number 4. We now have it in 1, 2, 3, 4 places, as you can see. So the first one, we have number 12 and number 4 normally closed. We have another one, number 11 and number 3, they are normally closed. Number 10 and number 2 normally closed. Number 9 and number 1 normally closed. So it means that if you energize this relay, all of them like that, they are normally closed. But when you energize it, all of them will open. They will now close to the number 9 and number 5 will now be normally closed again. Number 10 and number 6 will now close. Number 11 and number 7 will close. Number 12 and number 8 will now close. So immediately when power goes out, they will return back to the normal position. When power is restored, they will open again. They will do the other way around. So this is how this relay works, and I just want to introduce it to you. So if you want to learn more about this, just follow my page. I'll be dropping videos on how these things works, and I'll be teaching you how you can use this relay to perform any project. So I'm using this relay in an automatic changeover training, automatic changeover installation. As you can see, this is a contactor. This is a normally open contactor. So if you energize it, the contactor will close. You can see that it's different. Now when you close it, you can see that this one has different four places. So same way, this one can close in 1, 2, 3, 4 places. You understand? When this one is not energized, it will open like this. So these places are open, but you cannot compare this one with this one. This one can carry heavy load because it's rated 125 amps, while this one is just rated 9 amps. Do you understand? This one is just, in fact, it's rated 6 amps. So the load this one can carry, this one cannot carry. So we can only use this one to energize this one. We can use this one to energize this one, but we cannot use this one to power much load. Now let me tell you one secret this thing is replacing. There's one device this thing is replacing. I'm going to show you now. Welcome back. So introducing to you, this is we call this one auxiliary contact. This is what that relay is replacing. This relay is replacing this guy, because this guy is called auxiliary contact. It's usually installed on top of the contactor like this, so that it can give us that effect of normally close and normally open that we are looking for. Do you understand? Okay, we usually install it on top of this contactor, like this. Now, whenever the contactor is being energized, you can see that this thing is moving together with it. So whenever the contactor is working, it is going to move this thing together. And if you take a close look at it, you see that we have normally close NC, normally open, normally close, normally close. So meaning that when this contactor is energized, this place that is normally closed will turn to normally open. When it's energized, this one that is normally open will now be normally closed. Do you understand? So when it is de-energized, all this one that is normally closed will now be normally closed. This one will now be open. So the same way this one is doing. Do you understand? But we don't want to use this one because it adds more load onto the contactor. So it makes the contactor burn out quickly. So instead of adding this load on top of the contactor, the spring will be too heavy to push this auxiliary contact. So we now have to just do all the connections inside of this one, and it will make the work, to relieve the stress on top of this contactor. So I'm going to do that in a project where I will show you. I hope you enjoyed this class. Please give me a follow, give me a like, and I will show you more of this in my next video. Thank you. Bye. Peace out. I remain Solid Electrical.